All right, we have been talking about some calculations involving preparation of solutions. So for today, we are going to concentrate on volumetric or quantitative analysis. So in the course of this lesson, we are going to be looking at some examples or some calculations involving volumetric or quantitative analysis. Now, when we say quantitative or volumetric analysis, what are we talking about? It is a method of determining the concentration of a solution by means of titration. So, when we say titration, it is a method of trying to look for the concentration of a particular solution given the concentration of another solution. So here we shall be looking at two basic types of solutions. We're looking at the acid solution and the basic solution, or we are going to be looking at acid and base. So reactions between an acid and a base is simply referred to as a neutralization reaction. Now, the products obtained in the course of this reaction is simply salt and water, and sometimes in some cases we can also have carbon dioxide as one of the products. If one of the compound or one of the salt or one of the base that is used involves or it is a triisocarbonate 4 compound to produce carbon dioxide as one of the products. Okay, so in volumetric analysis, we will simply be looking at the concentration of a solution when the concentration of another solution is given. So either we can be asked to find the concentration of the acid solution when the concentration of the basic solution or the base is given, or we will be asked to find the concentration of the base when the concentration of the acid is given. So in some cases, either you can be given the mass concentration of one of the solution or the molar concentration of one of the solution. Then you will be asked to find the concentration of the other solution. So that is what we are going to be looking at in this topic. Okay, now when I say neutralization reaction, we simply talked about a reaction between an acid and a base to produce salt and water. So here we can have a common example of a neutralization reaction as a reaction between sodium hydroxide aqueous plus H2SO4 aqueous to give us sodium tetraoxosulfate 6 plus water. So this is a common example of a neutralization reaction or an equation to represent a neutralization reaction. We can also have a neutralization reaction where we can produce carbon dioxide as one of the product. So in that case, we can have sodium trioxocarbonate 4 as our base or alkalis. So plus HCl, hydrochloric acid. So this will give us sodium chloride aqueous plus CO2 gas plus H2O liquid. So these can be the products of the neutralization reaction. Of course, by balancing the equation, we have 2 moles of sodium chloride here. Then we have also 2 moles of HCl here. So these are two equations that represent a neutralization reaction involving an acid and a base to produce salt and water, while the second one produces salt, water, and carbon dioxide as the case may be. Now, in solving questions involving neutralization reaction, for the sake of this class, since we are not in a practical class, in a practical class you will be taught more on the method of dissolving and the method of preparing the different solutes or the method of dilution. Okay, so for the sake of this class, we are simply going straight to the calculation aspect. So in volumetric analysis, there is a simple formula that is called a volumetric analysis formula or the quantitative analysis formula also, and the formula is written in this form. We have CA VA all over CB VB is equal to NA over NB. Okay, so this is referred to as the volumetric analysis formula that is used to calculate either the concentration of the acid or the concentration of the base, and in some cases the volume of the acid and the volume of the base. So in this formula we have RCA to represent molar concentration of acid. Okay, so molar concentration of acid is RCA, that is concentration of the acid in mole per dm cube, while our CB here is molar concentration of the base. Our VA is equal to the volume of the acid, okay, while our VB is equal to volume of the base, while our NA here is number of moles of acid, while our NB is equal to number of moles of base. Okay, that is what each of the formula represents. Okay, so we have been able to analyze what each item in the formula represent. The CA represent molar concentration of acid in mole per dm cube, CB the molar concentration of the base in mole per dm cube, VA volume of acid in cm cube, while the VB is the volume of base also in cm cube, Na is number of moles of the acid in moles, while Nb is the number of moles of the base also in moles. So this is a simple formula that can be used to solve some questions involving volumetric analysis or calculations involving volumetric or quantitative analysis. Now, in using this formula, it is also very important that before you solve the question, a given question, you must first of all balance the chemical equation. The equation of neutralization must be balanced to obtain the accurate number of moles of both acid and base. It is very, very vital. Okay, so let's take a look at a simple example involving calculations in volumetric analysis. So we'll go to some worked examples. So the first question here is, what volume of 0.5 mole dm cube H2SO4, which is the acid, will exactly neutralize 20.0 cm cube of 0.1 mole per dm cube sodium hydroxide solution? Of course, we said a reaction between an acid and a base is simply termed neutralization reaction. Okay, so here the first thing we are going to do, we have our acid, we have our base. So our acid is H2SO4 while our base is sodium hydroxide. Okay, now sodium hydroxide is actually an alkali. An alkali is a soluble base or a basic hydroxide that is soluble in water. So we have our sodium hydroxide as our base or alkalis. So we are going to write a balanced chemical equation for the reaction between H2SO4 and sodium hydroxide, which is NaOH. So by doing that, we can have our solution to the question to be this. So equation of reaction. So our equation of reaction is H2SO4 plus sodium hydroxide will give us Na2SO4 aqueous plus H2O liquid. Okay, so this is our equation of reaction. Now, in trying to balance the equation, because we said for us to obtain the actual number of moles of both the acid and the base, we must try to balance the chemical equation. So taking a look at the equation, we have 2 atoms of sodium by the right hand side. So in trying to balance the sodium, just as we did in balancing of chemical equation in one of our classes, we simply add 2 moles of sodium hydroxide to the left hand side. So here we add 2 moles of sodium hydroxide to the left hand side, and we have balanced equation at the left hand side. Also, our hydrogen is 4 atoms at the left hand side, while at the right hand side it is 2 atoms. So we also introduce 2 moles of water to the right hand side. By doing that, we have balanced the equation element by element, compound by compound. So having gotten the actual number of moles of both the reactants and the products, we can now go further to write or to identify our number of moles for acid and base. So here we have 1 mole of acid and 2 moles of base to give us 1 mole of salt and 2 moles of water. So that is the balance equation. So from this equation, we can have our Na equal to 1, while our Nb is equal to 2. So Na and Nb can only be obtained from the balanced chemical equation. Take note, there are no two ways about it. You must first of all balance the equation, but in some cases, if the equation is already given to you and is balanced, then that makes the job a bit less cumbersome for you. So in this case now, the equation was not balanced, so we have to write a balanced chemical equation for the reaction between sodium hydroxide and H2SO4. So let's go further to see how we can input these values into the equation. So we have our formula for, so we can say using volumetric analysis formula, we have Ca Va over Cb Vb is equal to Na over Nb. Okay, so we can say where Ca is equal to, our Ca here is the molar concentration of the acid. So the molar concentration of the acid here is 0.5 mole per dm cube, while our Cb here is the molar concentration of the base and is given to us as 0.1 mole per dm cube. We also have our Va to be equal to unknown. That is what we are asked to find. We should find the volume of the acid that is used in the titration or in the volumetric analysis. Okay, so while our volume of base Vb is equal to 20.0 cm cube. Of course, during titration, the volume of the base is obtained from the type of pipette that is used in the question. So if you have the pipette that is given to you as 20.0 cm cube pipette, that gives you the volume of the base. If it is 25 cm cube pipette, that gives you the volume of the acid. So we have 20 cm cube pipette and 25 cm cube pipette. So in this case now, we are given 20 cm cube of as the volume of the base. So having done that, we can simply have our Na from the balance equation to be 1, while our Nb is equal to 2. Having done this, we can simply impute them into the question to have our CaVa Nb is equal to Cb Vb Na. Okay, so making our Va the subject of the formula, we are going to have Cb Vb Na all over Ca Nb. Okay, so Va now will give us 0.1 multiplied by 20.0 multiplied by 1 divided by 0.5 multiplied by 2. Okay, so this will give us 2.0 cm cube of acid. So this is the volume of the acid that is used in the question. Okay, so that gives us our volume of acid as Va. It is as simple as that. Knowing the number of moles of the acid and the base and the concentration of either the acid and the base, we can simply calculate the volume of the acid or the base in titration or in volumetric analysis. Let's take a look at our final question for today, and it goes in this form. It is given here as, it said, given that 15.0 cm cube of H2SO4 was required to completely neutralize 25.00 cm cube of 0.125 mole per dm cube sodium hydroxide. Calculate the molar concentration of the acid. Now, taking a look at the question physically, we have been given the molar concentration of the base. Remember, I said earlier that for you to calculate the molar concentration of the acid, you must be given the concentration of the base, either mass concentration or molar concentration of the base. Without that, you can't be asked to find two unknown. Okay, So you must be given one of the concentration, then you'll be asked to find the concentration of the other solution. Okay, so we are also been given the volume of the acid as 15.00 cm cube and the volume of the base to be 25.00 cm cube. Okay, so we also continue just as we did in the previous example. Our solution to the question is, we start by writing a balanced chemical equation between sodium hydroxide and H2SO4. Of course, it is the same equation as what we just did in the previous question. So we have our balanced chemical equation as sodium hydroxide aqueous plus H2SO4 aqueous. This will produce Na2SO4 aqueous, okay, plus water, give us liquid. So this is the balanced chemical equation. So by imputing our values here to balance the equation, we have 2 here and we also have 2 here. So this is the balanced chemical equation for the reaction. Okay, so our number of moles of base here is 2 moles, while the number of moles of acid is 1 mole. Okay, so that gives us 1 mole of salt and 2 moles of water. 2 moles of water. So we've now gotten the balanced equation and the number of moles of acid and the base. So Na here is 1 while Rnb is 2. So okay, so from here we have gotten our number of moles of acid and number of moles of the base. So we can now go further to use our volumetric analysis equation. So we say using volumetric analysis equation, okay, so we can have Ca Va over Cb Vb equal to Na over Nb. Okay, here we have our Ca should be equal to the molar concentration of the acid as the unknown. That is what we are asked to find. We have been given our molar concentration of the base as 0.125 mole per gm cube. Okay, and we have also been given our Va to be 15.00 cm cube, while our Vb is equal to 25.00 cm cube, while our Na is equal to 1, our Nb is equal to 2. So by substituting these values into that formula, what we can have is, we have Ca Va Nb is equal to Cb Vb Na. Okay, so by making Ca the subject of the formula, what we are going to have is Cb Vb Na divided by Va Nb. Okay, so with that we are going to have 0.125 times 25.00 multiplied by 1 divided by 15.00 multiplied by 2. So our Ca will give us 0.1042 mole per gm cube. So that is the molar concentration of the acid. It is as simple as that. It is simple, is it not? Now, this is a common method of determining the concentration of one solution or the volume of one solution when the concentration of the other solution is given to you using titration. Okay, so when we say volumetric analysis, we're simply talking about a method of determining the concentration of a solution using what? Titration. So there are so many ways you can find the concentration of a solution, but the simplest method here we can simply use titration to obtain the concentration of a solution. Okay, so with these few examples, I believe if you come across any question both in your JAM, WAEC, or any exam at all that has to do with calculating the concentration of a solution or involving the use of the volumetric analysis formula, I guess it will be a very simple thing for you to handle. Okay, so with this we'll come to the end of this class. So in our other classes we will be looking at other important concepts in the study of chemistry. I urge you to avail yourself in this platform where we are going to be discussing very important concept in the study of chemistry. So hope to see you in our other classes. Bye for now.